This is the first day of doing our most missed from our last few assessment items. So probably the most important days we do in here. I obviously don't hit what everybody got wrong. I just look at the data and I grab the ones that were obviously the most missed. If you got others wrong that you still don't understand, you should ask me separately, either during classwork time or out time or whatever. So the first ones are coming off of our Series B test. And this one was a preventable most missed, I think. I think it's my directive to you guys is just be careful with your signs and slow down. Because the answer that was chosen by most of you who got it wrong was, I believe, this guy. But let's go take a look. So we're doing our third degree Taylor polynomial. So we need to figure out f of x, f prime of x, f double prime of x, and f triple prime of x. And maybe along the way we'll be able to stop. So our f of x is the natural log of 3 minus x. And at 2, that would be the natural log of 1, which is 0. So this is going to start at 0, so nothing there. The next thing I need to do is do my u prime over u, which is negative 1 over 3 minus x. And then at 2, that would just give me a negative 1. So I'll be a minus. So these are out and these are out. It's going to be 0 minus and x minus 2 to the first over 1 factorial. And then my f double, I think this is where people goofed up. So when I grab my f prime, I'm not going to do my quotient rule on it, because when d lower d high is 0, it's usually easier to do another way. So I'm going to write that as negative 1 times 3 minus x to the negative first power. I'm going to power rule it. So that'll become a positive 1. And then it'll be a 3 minus x to the negative 2. But then I also have the derivative of the guts, which is negative. And I think that's what threw some of you guys off. So the next term is also going to be subtraction, so I don't even need to go to my third derivative. So I think that's where the issue came, is a lot of you neglected the derivative of the guts, and there are lots of negatives going on, so that's understandable. This guy, actually, I think only one person got right. I didn't look at who it was, but I always said that when you're stuck, you should write out the whole model. I don't want to write out the whole model, but I know that in it, if I'm looking for the 30th derivative at the center, it's going to be the coefficient of x minus the center to the 30th over 30 factorial. That's just our formatting. If I were to write them all out, it's the nth derivative, the nth power, and the nth factorial. So what I know is this coefficient has to equate with the coefficient of x minus 3 to the 30th power. So my x minus 3 to the 30th power is going to occur when n is a 15. And when n is a 15, I will have a positive, correct, a positive 1, because it'll be negative 1 to the 16th power. I will have an x minus 3 to the 30th. And that will all be over, my n factorial would be 15 factorial. So the coefficients have to equate. So if I'm solving this for the 30th derivative, I'd have to multiply both sides by 30 factorial, which is going to put 30 factorial on the top, and you get e. So it's just a matter of equating the coefficients. The coefficients were weird on that one. The next one was an AB guy, and there's a couple ways to do this one. This was number 11 on your 2012. So those were the top 2 missed on Series B. There were 15 multiple choice questions. Those were the 2 most missed. And then I grabbed this data off of your 2012, the Google Doc that you're supposed to put little asterisks by the ones you got wrong. So either you know what the graph of this looks like. It's sort of a it's a composition of 2 parent functions. It's an absolute value stuck under a root. I happen to know what the graph of that looks like, so that's what I would use. But if you didn't, Let's think it out. So whenever we have absolute value equations, they're piecewise functions. The absolute value of x is equal to x as long as x is greater than or equal to 0. It's equal to the opposite of x when x goes negative. And that holds for all absolute value functions. So I would have a piecewise function where that's actually going to be the square root of x minus 2. I don't need the absolute value bars as long as x is greater than or equal to 2. Then I don't even need them because what's under that radical is going to be positive anyway. But anywhere x is less than 2, like at 1 and 0, I do need the absolute value bars, but I can't think about derivatives with absolute value bars. So another way of saying I want to take the absolute value of something is to say I want to take its opposite. As long as that something was negative, which that something will be when x is less than 2. So really under that root, I'd have, it'd be equal to the opposite of what it is, or equivalently to minus x under here. To check for continuity, you just put a 2 in, and both of those are 0 at 2. To check for differentiability, you'd have to take the derivative of both of them at 2. And you can see that this one is going to have a derivative of the guts, which is negative, and this one's going to have a derivative of the guts, which is positive. So my derivatives won't match. There'll be 1/2 x minus 2 or 2 minus x to the negative 1/2, but then one of them is going to have the negative guts. So I know it's not going to be differentiable. Okay, I know it is continuous. My graph of that, though, looks like the square root of x minus 2 when I go to the right. These don't even need to be there. To the left of it, it shouts out that way, so it sort of looks like an absolute value graph, but my v has that curvature due to the root. So I can see I do definitely have a cusp there at 2. You can go check it out on your calculator. But my guess is most of you didn't know what the graph of that looked like, so then you have to, College Board loves to have you work with, like, say, the absolute value of x minus 5. And when you don't have a calculator, you're not calculator active, sometimes you have to say, all right, well, that means it actually is x minus 5. When x is 7 or 8 or 9, I don't even need the absolute value bars as long as I stay above 5. But when I go below 5, I'd have to take the opposite mathematically. Like if x were a 1, I would do 1 minus 4, but I'd have to take the opposite of it, which equivalently would be 5 minus x. So just sort of keep that in mind. They kind of like to do that. Number 12 was also in the most missed. It's also in AB. And it has to do with local maxes and mins when you can't make a sign line. So we know that we've got these 2 points on the graph, okay? The first thing I would do is see what the derivative is there, okay? So my dy dx at -1, -1 would be equal to -1 squared plus a -1, which is 0. So I do know that this is a critical value of f of x. But I can't check to see if there's a sign change to the left and to the right to know if I have the plateau, the max, or the min. So what happens is you have to use the second derivative test. And let's review what that says. The second derivative test says that if your second derivative at a critical value, which I now know -1 is less than 0, it means your function was concave down at a critical value, so you had a max. If it was greater than 0 at the critical value, it being the second derivative, then we'd be concave up and have a relative min. So I need to take my second derivative, which would be the derivative with respect to x of x squared plus y, which would equal 2x dx plus dy dx, which is x squared plus y. Okay, so I needed to take a second derivative. You use that second derivative test for extremum when you have no way to make a sign line. I have no idea what's happening directly to the left. You could say, well, I tested -2 and negative. You have no clue what's happening at -1.000000001 or even closer than that. You need, when you're given the derivative and not the function itself, you're going to need that second derivative test. So we're doing this at what? -1, so that'd be a -2 plus 1 minus 1. It's going to be less than 0, which means I'm concave down at that critical value. So I have a local maximum for sure, correct? And I also know it won't have a point of inflection because, so I'm going to, the second derivative has to equal 0, and right here it did not. Let's check and see what happens with 1, -5, to see what that gives us in terms of our first derivative, because it has to be a critical value for it to be considered for relative extrema. So that's obviously not going to equal 0. So definitely not. This is in the running, right? And there's only one choice, so it's got to be C. All right, I guess I don't even need to eliminate those other ones. I love this question, number 22, because it means you need a really deeper understanding of what a power series is. So there is something in front of here. Perhaps it's an alternator, or it doesn't particularly matter. You know that this is x minus c, or that your center is at 3. So you have some function being approximated by a power series, okay? And let's just go draw the function. It is centered at 3, all right? And it says that there's convergence at 5. So we definitely would have had a beefy at 5. So I don't know what's going on here, but I know I definitely have convergence up to and including 5. What that means is my radius of convergence at a minimum has to be 2. I am straying 2 units to the right of the center and I'm converging, which means if I go 2 units to the left, I may or may not converge. I don't know. But everything in between there has to be within the radius, which is 2, of convergence. So I'm searching for, do I know we diverge at 0? No clue. Do I know we diverge at 1? I only know that it's beefy or wimpy, and I have no way of testing it. Does the series converge at 1? Again, I don't know that. Does the series converge at 2? Definitely, because 2 is in the radius of convergence. So I know that this is matching right up to and possibly including this. You can stray the radius of convergence from the center, which at a minimum would have been 2. It could have been more. All right, number 78 was in our calculator active and also a most missed. So this is also an AB question where we bring constants out front. You can deal with that two ways. I'm going to deal with it both ways. All right. So really what I need to do is triple what I get when I do the signed area from -1, which is this guy, which is 1, 2, 3.5. So -3.5 because it's under, or the f of x would be negative. And then I need to add this to it, a half of the base, which is a 6, and then times 2, so that's 12. A half of that is 6. So I have my -3.5 plus my 6. Okay, that's this piece of it right here, guys. I need to triple it, and then I need to add to it. Now, there's 2 ways to think about this. This is the function f of x equals 2. It's a horizontal line up at 2. We are evaluating it from -1 to 9. It's going to contribute a 10 by 2 rectangle. Or The antiderivative of 2 is 2x, and we're going from -1 to 9. The fundamental theorem of calculus would be 18 and then minus a -2. So either way, visualizing it as a rectangle with a 10 by 2 dimensions, or using our fundamental theorem of calculus and finding the antiderivative of 2, plugging it in and all that good stuff, do the arithmetic, and you get 27.5 for that one. 18 is a little tricky. It's got a little pre-calculus in it right here. I'm not sure if you guys remember what that means. If f of x is equal to this, it means that, what would be a good way of putting it? It flips it over the x-axis because the y's become opposite. Okay, that's what f of x is, a y. So positive y becomes a negative y. Okay, f of negative x flips it over the y-axis. So you kind of need to know that what happens at x's y value is going to be the same as the y value at the opposite of x, if you were to sort of sort that out. And that's important because they give me a screenshot from 0 to 1, but not from -2 to 0. So I have to know that whatever happens, it gets reflected over the y-axis. What happens at x is also the same as -x. Okay? So, having said that, we've got to go analyze what's happening on our graph here. First of all, we're twice differentiable, which means these are smooth, they're continuous, there's no cusps, there's no holes, there's no asymptotes. It's all beautiful. This means I'm above the x-axis and decreasing and concave down. So from above the x-axis, I have to be the decreasing part of concave down. So it means, I don't know how high, it means I'm coming in like this. From 0 to 1. Excuse me. So I'm coming in like this from 0 to 1. And it doesn't matter how high up I am. I just know that I'm concave down because of the negative second derivative. I am decreasing and I'm above the x-axis. Then from 1 to 2, I am below, I'm still decreasing, but I'm concave up. So I'm the decreasing part of the concave up. No cusp being made. So that's sort of what I would look like from 0 to 1. I'm using these above, decreasing, concave down, below, decreasing, concave up. And then I'm going to reflect that this way. So that's just sort of what a graph of it might look like. But even from the table, if we have a change in concavity right here at 1, and it's differentiable, it means we have an inflection point there. So for sure at 1, but because of the symmetry with the y-axis, because of that, I'm also going to have a change in concavity at -1. So that one required a little bit of pre-calculus knowledge. This last one's really weird. So the function h is differentiable, it's also continuous. H of x is h of 2 minus x. Which of the following must be true? So I think the first thing I want to do here is talk about what h prime is, because we've got some h primers here. So h prime of x will equal h prime, the derivative of the left, will equal the derivative of the right with a negative fraction correction. Because this is a composition, so we do the derivative of the outside times the derivative of the guts. Okay? This first one is talking about, well, what, and I'm ignoring this guy right now, I'll come back to it in a little bit. All right, so this one's saying h prime of 1 has to equal 0. All right, well, h prime of 1 is going to equal the opposite of h prime of 1. There's only one number in the world, regardless of what this is, where it is equal to the opposite of it, and that's this one. It says h prime of 0. Well, h prime of 0 would equal the opposite of h prime of 2, Well, it doesn't equal h prime of 2, correct? So then our last one up there is the first one. I'm just doing this by trial and error. I don't know. Maybe some of you have a better way of doing it, but I'm just working with it. This one says, do I know that the net result between 0 and 2 has to be positive? Whatever the graph of h was. And I just don't know how I can even show that. So I'm going to go with B, which is the right answer. I have no better way, though, of getting that answer, except for by brute force checking these and being like, well, what the heck is that? Why would it have to be positive? I don't have a better way. I don't know how Mr. Calculus did it. And then our last two. Most missed on our polar parametric. This guy's so easy to fix. This was a sloppy mistake, so I'm going to write sloppy. You have to be careful. We know the formula is that we integrate from theta 1 to theta 2 r squared, and I think those of you who got it wrong were like, oh, there it is, it's D, but it's 1/2 of that, so it was C. So just be careful. That one almost didn't make the most miss, but there were enough, and it's such an easy one to fix. And then last up, we had a polar. There weren't any parametric that fell in the most miss, and that didn't surprise me because that's been a strength of yours whole year. All right, so we've got these two functions. It was calculator active, so if you weren't sure which one was the cosine, but we know it goes like this. Actually, furthermore, it starts over here at 0. Right? Cosine 0 is 1. It goes this way, pi over 2, and then cosine of pi is -1, which is why when we face in the pi direction, we have to go backwards. So this one is curving along like this. The other function is this guy, which they said is 2 theta. So when I start to color here, I'm going from the pole, and I'm making these radii out from the pole, and I'm hitting that first curve in there first. So as I travel along there, I'm going to have 1/2 the integral from 0 to the intersection, which they were nice enough to tell me, of r squared. Well, that one is the 2 theta. Okay, that'll color in this. Once I hit 0.450, my outside function that gets hit changes. So I'm going to go from 0.450 to, and then be careful, but because I bet one of these answers is a pi being there, but cosine of pi halves is 0. Starts at 1, 0, and then all the way back to -1 at pi. So it does a full circle in the domain from 0 to pi, not 0 to 2 pi. So that might have been one of the mistakes. We need a pi over 2 here. I'm going to parenthesize that so I don't have to try to squeeze a half in there. And then we have the 2 theta quantity squared. No, we don't. We have the outside function, which it changed to cosine theta. I'll embed the squaring d theta. You run that through your calculator, okay? And you should, and you'll get this one. So that's our most missed. If you have questions on any of the other ones that Mr. Calculus or just looking at keys didn't help you, let me know. I believe that's the last one. Yep, it is. So really no assignment today. It was to watch this, get caught up, get things made up, and if you want to do that Delta Math extra credit, there's 2 parts to it. The first part is if you make it on the leaderboard, so 100 plus points, you're going to get 5 extra credit test points. If you're in the top 3, you're going to get lunch from the Hallway Cafe, purchased by yours truly, Mrs. LaRudy. Peace out. I am Mrs. LaRude.